Okay, we're on the second part of Unit 6B here. It's the homework from last night. Okay, so we're talking about the margin of error, decreasing the margin of error. In general, we do want small margin of error, right? So how can you get the confidence, the smaller, how can you get the margin of error smaller? If you decrease the confidence level, that's not a great option, just to be honest with you. So we don't really, I'm 10% confident that this interval contains the true proportion. Like, we don't love that option. We don't usually use it, but you could use it to decrease the margin of error. But the good way to do it would be to increase the sample size. So that's always good for, samples here. So take a larger sample size. That's going to reduce the margin of error. It costs more to do that. Yeah, I mean, that's the drawback, but it is nice to do that. Okay, in the cell phone example, we were 95% confident that the interval from 0.2 to 0.261 captures the true proportion those who admit to walking into something or someone. The interval is based on a random sample of 738 cell phone users. Explain what would happen to the width of the interval if the confidence level were increased to 99%. So if I said, I'm 99% confident the interval from blank to blank, would that have to be a wider interval or a more narrow or smaller interval? So if I'm 99% confident, I'd have to actually widen the interval. I'd have to say, maybe from 0.1 to 0.4 or something like but I'm really sure it's going to be in there because we're 99% sure. It would have to be wider, increases the margin of error. So it's kind of a two-way street. So if you decrease the confidence level, it's going to be a narrower interval. I'm not too sure, but it's in this small little interval here. How would the width of a 95% confidence interval at a sample size of 1,500 compare to the original 95% interval? So in other words, if we increase the sample size, what's going to happen to the margin of error? Is it going to get smaller or bigger? Increasing the sample size is good. That's going to make the margin of error go down or get smaller. Decreases the margin of error with everything else stays the same. Okay, the margin of error does not account for any sources of bias in the data collection process. Oh, interesting. So that's not a source of bias. Okay. To determine the sample size n will yield a certain confidence level interval for a population proportion p with the maximum margin of error. Solve the following inequality. So this is really the inequality. Remember, if you remember the interval, if you multiply the z critical value times standard error, that's your margin of error. I think the reason we're saying less than or equal to is we're trying to determine the sample size n, and so we want to, usually they have a goal for the margin of error or something, so we want to determine the number, the whole number for n that would make it equal to or less than the margin of error there. If p hat is a guessed value for the sample proportion, so that's kind of interesting. So sometimes we don't know enough information. This is something we're going to do. We'll see if we have a problem like this or not. But occasionally we have to say, well, we're missing like 2 or 3 of those. We're missing a couple of those variables. And so we'll put in a kind of a guess for the p hat there, and we'll just kind of guess generically 50%. If you think about it for like an election, it's not a bad guess, right? Usually both candidates are somewhat close to 50% if it's a close election. So put in 0.5 for p hat is sometimes something we do. We'll see if we have to do that in one of these problems or not. The company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size would be required, like how much is it going to cost me, as the company president's thinking. One value of interest is the proportion P of customers who are satisfied with the company's service. The company president wants the estimate to be within 3 percentage points at a 95% confidence level. How large a sample is needed? Okay, so let's kind of get the formula here and fill in what we can. So I think the formula is Z critical value times the square root of P hat times 1 minus P hat over N. And we think that's going to be less or equal to the margin of error. So they did tell us some things here. They said that the margin of error is going to be 0.03. So you're adding, subtracting 3 percentage points. They said the confidence level is 95%. If you remember, the Z critical value for that is 1.96. You could also work that out. You could do a normal curve, 0.95 is in there. So then you do inverse norm for 0.975 to get that 1.96, because there's 97.5% of the data to the left of that value. And then you go square root of, so we don't know both of those variables. We're trying to find N, so I know we don't know N, and we're trying to find it. We don't know P hat, so what we do here, it's kind of sketchy, but it's okay. We're going to put 0.5 in there. We're just going to kind of say that's our best guess. It's a pretty safe, it's not too risky of a guess, I guess. And so we're just going to use that. And because of the stat class, if I were you, I would probably just solve that in your calculator. So go to the solve command menu. 3 is algebra and solve there, or nsolve. You have the Inspire CX. So 1.96 times square root. Oops. So let me put my cursor there, control divide. So we have 0.5 times 1 minus 0.5, or 0.5, I don't know why I put that. Could have just put 0.5, divided by N. And then of course at the end of it, you have to put comma and the variable you're solving for. Oh, it would help, I didn't see the whole equation there. It's equals 0.03. It was kind of covered up. Actually, it's less than. Let's see, so to get a less than, let's see if this will work. I think it works, but it's been a while. Less than 0.03. So that's what, if you look at the actual equation, that's what the equation was. It was covered up and I just didn't realize there was an equation there. And we get N has to be bigger than or equal to 1067.11. So N is greater than or equal to 1067.11. Okay, so how large a sample is needed? So typically what we do here is we're going to round up, right? So we're going to say 1068, I believe. Let's see what they did. They use math to solve, by the way. So we need 1,068, at least 1,068 customers to have a margin of error of 0.03 or smaller, essentially. So that, or smaller is the idea there. Okay, so that's the lesson for today. In July 2020, during the COVID pandemic, dogs were trained to detect the scent of coronavirus on human saliva. These dogs correctly detected the presence of the, or absence of the virus in 94% of about 1,000 random saliva samples that were given. The 95% confidence interval for the true detection rate of the dogs is 94% plus or minus 3.4%. Explain what would happen to the width of the interval if the confidence level will decrease to 90%. So it seems like what would happen, you decrease the confidence level, that it's going to get more narrow, right? So it's going to decrease the margin of error. How would the width of the confidence interval based on a sample size of 400? So if we had smaller sample size, that's going to increase the width. That's going to be bad, right? So increases the margin of error, so increases it. Social media is everywhere, it seems, but does increased access to social media also mean people feel more connected to others? A recent question in a Gallup poll asked in general, how connected do you feel to people? By connected, I mean, how close do you feel to people emotionally? Wow, goodness, some feelings in math. We wish to estimate the proportion P of US teenagers who feel very connected to others within 4 percentage points with 99% confidence. How large a sample is needed? So let's get out our formula here and see what happens. So we're going to say Z critical value 99% to, I don't know that one. Well, maybe I do, but 0.99. So in your calculator, you can do inverse norm. So inverse norm 0.995, comma 0, comma 1. I think that's the syntax. 2.58. So Z critical value is 2.58 from, because there's 99.5% to the left of that. So we're going to say 2.58 times square root of less than or equal to 0.04. So we want within 4%. I think that'd be 0.04 there. We want to try to find the sample size. Did they give us the, they did not give us p hat, right? Okay, so we're just going to say 0.5. And so that'd be 1 minus 0.5 or 0.5. So let's type that in our calculator. So solve 2.58 times square root of 0.5 times 0.5 over n less than or equal to control equals 0.04 comma n. So 1041, I believe, would be the number. Let's see what they did. Oh wait, what did I do wrong? 0.5 times 2.5. Okay, so they, and both answers would be correct. We showed our work. I rounded that to 2.58. They kept it 2.576, and they got a slightly different answer. Is that okay? Yes, that's okay. So show your work. You're good to go.